In this video, we'll look at the useState hook, which lets you add state to an otherwise stateless function component. We've established the fact that function components, when compared to class components, offer a cleaner syntax that is easier to read, understand, and debug. After all, they're just simple functions that accept arguments and return React elements. But function components do not offer standard React features like state, side effects, and context. For instance, state is a fundamental React feature, and while class components offer built-in state features, a function component lacks the ability to offer stateful properties. With the Hooks API, we can easily plug in state to a function component using the useState hook. And the proof of the pudding is in the eating. So let's work through an example. Begin by downloading and setting up the project and kickstart the development server. Our app here produces a UI that would typically be part of a social media product. We have two configuration options here, each of which carry a widget that looks like a toggle button, but in fact just displays a static on or off state now. Below these configuration settings is a feature that lets users type in and add tags like hashtags for a post. The app itself is a function component where we have two instances of a config component that renders our configuration settings. For the state of the toggle button, we are currently passing in a static true or false to the toggle state prop, which visually changes the state of the button as you can see here. Then we have the tags builder component that renders an input field and a set of tagged keywords, which we are currently passing in as a static array to the tags prop. So if I add an element, it appears on the UI as you can see. We also have an add tags prop that uses inverse data flow to bring up the value of the input field once the user types something and presses enter on the keyboard. At the moment, we are not storing this value anywhere. Now, the config component simply renders a text title that we get in the title prop along with the words off or on depending on the value of the toggle state prop. We are also rendering an instance of the toggle button component where we are simply passing in the value of the toggle state prop to the init prop. Inside the toggle button component, the value of the init prop, which would be either true or false, is being used to conditionally switch CSS class names, which is how we get our off and on visual states on the UI. So this function component will be our first stop as we add state. We want to turn this static button to a dynamic toggle switch that the user can click to enable or disable a given feature. For that, and to turn this into a reusable component, we'll need a local state property which stores the off or on state of the button. So let's first bring in the useState hook function from the React library like so. This hook will allow us to create a state property as needed by our function component. The useState hook provides us with two things, a state property and a function that updates the value of the state property. These can be extracted using array destructuring like so and set to the invocation of the useState hook function. So what we are saying here is that isOn is a state property and setIsOn is the name of a function that updates the value of the isOn property. We've used camel case for declaring these items, and that is a convention that you should follow too. Notice how I've initialized the state property at the top of the function and outside the returned React elements. This is important. Hooks must always be initialized at the top level and never inside conditions, functions, loops, or other structures. The useState function itself can also take an argument which can be used to set an initial value of the state property being initialized. This is not necessary as such, but I would strongly advise setting it because it allows React to correctly understand the data type when you use the updater function to set a value to the property. So the initial state could be a boolean, a string, a number, an array, and others. You can also use a prop such as our init prop to offload the task of setting an initial value to the consumer. This way, when using the component, we can simply set a prop to an initial value and the same would be set to our internal state property. And this is what we want here. We want to drive the initial state of the toggle button externally from the parent component. If I try to click on the button, nothing happens yet. So I'll create a function named toggle button state. This function will simply check to see the value of the isOn property. And if it's true, we'll use the setIsOn function to set it to false. And if the value is false, we'll toggle it back to true. This is how simple it is to create and update state properties using the useState hook. I'm sure you can appreciate the cleaner and simple to understand syntax. To use this function, we'll simply use the onClick property on the root div here like so. Lastly, instead of using the init prop to drive the conditional CSS, we'll use the isOn property. With this done, you can click on the button to toggle it easily. We've just turned a stateless function component to a stateful function component using the useState hook. Pretty neat, don't you think? But toggling these buttons doesn't change the intended state of these settings. This is because we want this button component to pass its state up the chain using inverse data flow, so we can use the button state for affecting data at the parent level. I'll thus create a prop named toggle and we'll simply invoke it with the button states like so. And just so that we don't get any errors, we'll set the default value of these props as well. We'll also go back to the config component and pass up the toggle prop as onToggle like so we can set its value from the config component itself. You can also use context here, but since it's just one level deep, we'll just forward the prop as shown. This now allows us to bring up the value of the toggle button to our app component using the onToggle properties on our instances of the config component. At this point, we need to turn our app component from a stateless function to a stateful function component so that we can store and sync data for our 3 component instances here. Once again, we'll begin by importing the useState hook first. Then we can create 3 state properties beginning with the scheduler and its setter function setScheduler, which will hold the state for the useScheduler config component. Likewise, we'll create a state property to hold the state of the useLocation configuration, and we'll set this to false as well. Before going forward, I would like to stress here that when using hooks, and unlike the state object in a class component, we need to create separate and individual state properties using multiple invocations of the useState hook function. You should never create a single object with multiple properties because the setter function will update the entire object and not individual object properties, as how it works when using setState in a class component. Now back in this example, we'll now drive the toggle state prop for our config component instances using our newly created state properties. You can now see updates to the button state if I change the initial value of these properties. But we're still not driving changes to these properties using our button. To achieve that, we'll run our setter functions in the onToggle prop like so, passing in the value received from the toggle button component. Now, if you toggle the button, you can see the state of our configuration change from off to on and vice versa. Let's create one more state property named tags with its setter function setTags, and we'll initialize this as an empty array because this will serve as the stateful storage for our tags builder feature. We can then drive our tags prop using the tag state property. For the add tags prop, we need to add and update the tags state array with the newly received value from the add tags prop function. The easiest way to do this is to invoke setTags with an array where we'll use the spread operator to first bring in existing objects from the tag state array, and then we'll add our brand new tag by creating an object where I'll set a unique identifier key named ID first to a unique value, and we'll set title to the value received from the component. Inside, the tags builder component simply uses map to map the array of items received in the tags prop to instances of a div with a class name tag. The unique ID is used as the key. This now allows me to dynamically add tags, as you can see. And that's it. We've easily added stateful properties to our function components in this example using the useState hook function. As you saw in this example, the useState hook function is amazingly simple to use and offers a straightforward way to add stateful properties to a function component. You can also set initial values to state properties by passing a value as an argument to the useState function. Additionally, this can also be a function which can be used to compute a value first, as seen here. And remember, you can create as many stateful properties by simply using the useState function as many times as you need. This, on the other hand, should never be done. The reason is simple. When using the setter function, the state property is set as a whole, and if you use this convention, as in the case of class components, you'll simply end up overwriting the state object structure. We do have a solution for this, which you will see later in this module. Alright, next up, let's see how we can bring in side effects to a function component using the useEffect hook.